اوكي. السلام عليكم ورحمة الله وبركاته مرة ثانية. تكلا بشكل عام they have three main softwares or three software packages. واحد اللي هو تكلا TED for element design, and then we have Tekla structural designer for an entire building design, وفي تكلا structures splitter. تعال قدام عشان صوت ما بتسمع. Okay, are you able to hear brother? Okay, if you can hear it's fine, up to you. See here at the beginning when you open the software, it says for you home and windows. Home, in which you can open new file or you can open an existing file. As well, you can put the settings in terms of the codes. You can specify the material. It will calculate for you embedded carbon emissions as well. Embedded carbon in terms of how much carbon is going to be produced while this particular element is made. So if we are having, for example, a concrete of 200 into 400 beam with certain span, it will tell you while you are constructing this or producing it how much carbon dioxide is emitted to the environment. Are we clear? Okay. And then update and then checking for license. Now you need to know that there are two versions, or actually three versions. There is one version which is trial version. It will be open only for a certain period of time and normally 45 days. Then after the 45 days, it will lock. Whatever file you have done within the 45 days, it will never be opened in any version. Okay. Second is educational version. It is a full version, but it will not allow you to have the reports. Okay. So you cannot get the output from the software. It's only to demonstrate. Okay. Not like Autodesk, Revit, Robot, AutoCAD. They will be writing for you that this is produced by Autodesk Educational. Okay. Now here it will not happen. It will only be inside the software. Okay. And there is the full version or the cracked version, in which it has all the facilities. Okay. So if you want to demonstrate in terms of the projects, only demonstration, you don't want to have the output and it's okay with your supervisor, then it's better to go for educational. Okay. Now if it's not, then you might go for full version. Once again, in educational, if you started working in educational, you cannot take it to full version. It will not open. Are we clear? The only workaround is to send it to Revit, and then from Revit once again to send it to Tekla, full version. Some mistakes might be appearing, especially if you are having, let's say, not symmetrical arrangements. I'm going to show you how to transfer between the two software, and then the loading as well. In most of the scenarios, when you transfer from Revit to Tekla, the loading will be fine, so you need to remodel the loading once again. Are we clear? Okay. Windows, it will show you the windows. Whatever window you want to hide, whatever window you want to show. Are we clear about this? Okay, we'll go to new home. Or before going to home, I will show you settings. Some of the settings can be shown here. So you can see that you are having UK as your main code and different things are there. Okay, now at the beginning when you install the software, it will ask you which region you want, whether it's a UK, whether UAE, whether USA, different things, and you can change as well, and I'm going to show you how to change the code later. Okay, design codes as well, it will show you here. The active is UK setting. Inside UK there are different there are different codes as well. So you can use Australia, you can use Euro codes from Europe, India, Ireland, Malaysia, and Malaysia they are using BS and Euro code, so it's up to you. Singapore they are using BS Euro code, and it goes on. Are we clear? United United States, they are using the American code. So different codes are there. Okay. Now, whenever you change from one code to another code, the codes that the software will choose will be changed automatically. Like for example, now if it's BS, you can see it's BS 6399 part 1, part 2, part 3, UBC, and it goes on. And then here, for example, if we go to India, you will see this will be changing according to the Indian code. If you are changing it to Singapore, then it will give you the corresponding codes. If you are going to Euro codes, then it will give you the corresponding one. Are we clear? Okay. So we'll go to BS. That's the United States or United Kingdom BS, and you can see these are the recommended ones. and this is a BS8110. This is BS5950. Different things when it comes to the code. Are we clear? Okay, so by default it has been chosen. Similarly for the materials, if you are using the British standard, you can see that you are going to have different elements. Like for example, in terms of material, these are the grades of steel which are available for structural steel. For concrete, these are the available concrete grades, and you can add whenever you want. You have normal weight and you have lightweight as well. Reinforcement, rebar, you can see that here it's 500. Okay, you can use 500 or you can use 460. For 500, they already defined the sections. For 460, the sections are not there. It means that if you want to use 460, you need to define the sections. Okay, when we say define the section, it means that it will include all of these things. The diameter, the area, it will be calculated automatically when you input the diameter. The maximum bar length will always be 12, and then the software will give you an indication how much is the mass per length. Okay, so these will be available if you are using 500, and once again there is no difference between using 500 and 460. Are we clear? So we will go for new file. Okay, now when we go to the new file, you can see that we have structure 3D, and we can use, or we can have base 2D. So one view is going to be for 3D, one view is going to be for 2D. Now a new what you call new headings came in the ribbon. Previously it was only home and window. Now you have BIM integration, model, edit, load, analyze, design, foundation, report, and then draw. Are we clear? BIM integration, if you want to transfer from software to software, it is all about BIM integration. Okay, Revit, if you want from Revit, all about BIM integration. Model, if you want to draw anything, it's model. If you want to edit, copy, paste, copy the load, then it's in edit. Anything related to the load, putting the load, putting its value in load. Analyze is for analysis. Design is for design all the elements except foundation, where the foundation will be drawn and designed here. Are we clear? Okay. And then reports, if you want to generate the report, you can get it from here. Drawing, if you want to have the drawing from Tekla to AutoCAD, then from here as well. Okay, and then window once again to hide and enhance. Okay, now the first thing that we want to do, we don't want to bring from Revit. Okay, and we don't want to send it to another software. We want to draw here. Okay, so we will go for model, we will not go for BIM integration. Okay, now first thing that you are going to go for model, you can see that there is a small button at the top left. It says for you construction level. Can you see? Now construction level, when you click on it, you will see a window coming. It says for you base. The name is base, and then you have type. There are three types: TOS, SSL, and TOF. I'm going to explain them. Now here you can input your name or the name of the floor that you want. So for example, this is going to be foundation. Okay, and this foundation is going to be for me at a depth of minus 1.5 or 1.8. Depends on your project. Now here we need to understand what is the different things that we are having. TOS is referring to top of slab. SSL is referring to structural slab level. TOF is referring to top of foundation. So if you are building a foundation level, then it's going to be top of foundation. Are we clear? If I go and change it to structural slab level, you can see that this is active now. When it comes to slab thickness, you can input the value. If I go to structural slab level, any slab level, then you can see once again it is active. If I go and change it to top of steel, it will be hidden. Are we clear? So once again, the places where you can put slabs are two: structural slab level and top of foundation. Top of foundation if you are only referring to foundation level. SSL if you are referring to any other floor. Are we clear? If you are modeling for length beam where there is no slab actually, for the design, not for construction, you will go for TOS. Are we clear? Because there will not be any slab. Okay, now for foundation, it's top of foundation. I just kept it to be 1.5. I will not change anything here. We have unique and we will see later what does it mean. We will go for insert above. I'll just put one floor above, and this floor I'm going to call it as GF. Okay, and automatically you will see the software is going to put for you, returning it back to 0. It means the height from foundation to ground floor is going to be 1.5. Okay, and now here we need to change it because there is no slab in the design. We need to change it to structural slab level, and you can see, or sorry, we need to change it to top of steel, and you can see that the slab is now what you call inactive because there is no slab in that level. Okay, after that I'm going to insert above as well. I'm going to have it as, for example, first floor. The height of the floor, for example, is 3.6. So you can see now, started from 1 minus 1.5 to 0, the height is 1.5. From 0 to 3.6, the height is 3.6. Okay, and then we will add, for example, insert above, and add one more, which is second floor or roof. Okay, now here there will be a slab, so I'm going to change it to structural slab level. Here there will be a slab, so I'm changing it to structural slab level. Are we clear? You can see you can see when it comes to foundation there will always be thickness because there is a slab, whether it's raft foundation or it's isolated or combined. When it comes to ground floor, we are not modeling a ground slab, so it will not be there. For the other floors there will always be a slab. Are we clear? Okay, so now we have defined. After you define, you will see that this has been changed automatically to foundation. I'm going to open all the windows at one time. So this is this is ground floor, this is first floor, and this is second floor. Okay, so now I have opened all the views, so it will be easier for me to track 3D, foundation, ground floor, first floor, second floor. Are we clear? Now after I have put the views, I'm going to go for the next step to put the grid lines. Now for the grid lines, the easier method is to go for rectangular wizard. So you can see now here, do you want your grid to go from the beginning till the end, or you want only the grid to be available only at a certain level? Now certain level, if it's too complicated for you and you're having a lot of variance in the flows, otherwise it should be the same grid. Okay, next it will start what origin, from which point. You can see that the origin is moving. Can you see the numbers here when I move? Can you see at the mouse position? Okay, now we don't want them. Normally we want it at 0 and 0, so I'll just keep it as 0 and 0. Now here they are asking you what type of line. That does not matter. Is it dot? Is it straight line? Is it continuous? That will not matter in your analysis and design. Now this is very important. It is asking you now, in terms of x direction, are you going for regular or irregular? Regular means all the spans are the same. Now how many here it says for you? How many bays? How many here it says for you? 4. It means 1 in terms of x. This is bay number 1, bay number 2, bay number 3, and this is bay number 4. So there are 4 bays. Each one of them is 6 meters. Are we clear? Okay, now we don't want it to be in that way. Normally it will be only irregular. Okay, so we will go for irregular. This will appear for it. Now how many lines are there? It returns only to first element, first line. Now let us say, give me one dimension. Give me one what you call, one distance. Any distance, give me any distance. 5. So 5, it will show you 5. Are we clear? Now, in order for you to write the second number, you need to go for comma. Okay, so comma, and then you enter the second number. So for example, 3. So the 3k. 7, 7k. Are we clear? If I write 2 into 3, then the software will understand for me that you want 2 bays of 3 meter. Are we clear? 2 into 3 means 2 bays. Each bay is 3 meter. Are we clear? If I'm having it as 3 into 5, the software will understand that there are 3 bays, each one is 5 meter. Are we clear? Okay. Understood? Okay, I'll not go for a very detailed one just because of the time. So I have specified for x. Now you can see for y, do we have same dimensions? For y, for x, are they different? For y, same, right? Okay, so we need now to change to y. So we click on next. It is asking you for y. Are you going regular or irregular? Now you can see here it's regular. And how many bees? Six. So one, two, three, four, five, and then six. Are we clear? Now we are going to change it to irregular, and you can input any values. So seven, uh, five, 6, and then let's say 2. Are we clear? Okay. Next. Next. Do you want to rotate it? Do you want it to be in a certain angle? What type of, what you call, sometimes my building, or let's say my block is not straight. It is tilting by a certain degree, so you can tilt your axis as well. Okay. Now we will keep it as it is, as 90 degrees. Okay. 90 degrees, and then this came for you. Now you can see the grid has been drawn in all the levels. So it's in foundation, it is in ground, it is in first floor, and it is in second floor. Are we clear? Okay. Now normally we start drawing from ground floor. Okay. Now after we finished from the the floors, we finished from the accesses, we are going to draw. Now here the items are for steel, as you can see. Here the items are for concrete. Here it is for slab. Here it is for timber. Normally we are going for concrete. So I'll go first and draw columns. Normally we start columns. So I'm going for a column. You can see now a small window came here. It will ask you certain details that you need to fill. Okay. So first thing, it asks you if you are going to rotate this or you are having it in the same orientation. I'm going to show you how it differs. Are you going to use normal concrete or are you going to use lightweight concrete? And then after that, it will ask you what type of grade that you want to use, and then what is the size of the, what you call, size of your column. So for example, I want my columns to be starting from 200 into 400. Okay, so what I'm going to do, it is 400 into 400 only. It will show you new and edit. So I'm going to go and put my width to be 200 and my depth to be 400. Are we clear? And then let's click on OK. Now when you go and see, you will see two sections are there. 200 into 400 and then 400 into 400. Are we clear? If you have another section, then add it and it goes in. Okay. Now after that, it says for you automatic alignment, and this is very important. You need to understand. Now it depends from where you are going to draw your grids or from where you have measured your grids. Some of the people, what they will do, they'll put it in this way and they will keep the automatic alignment. The software will understand that this is going to be the last grid. Okay, now the software is understanding that this is the last grid, and my column should be inside, it shouldn't be outside. Okay, now for us we need to understand whether these grids are measured from center to center or measured from the beginning. If it's measured from the beginning, okay, if it's measured from the beginning, then this is going to be the border of the building. Are we clear? Now no columns could be outside. Are we clear? If we are measuring our grid line from outside, then no column should be inside, like this one. See this one? Where is the end of the column? The end of the column is with the end of the building. Are we clear? Now you can see it in this way. It is not going outside. That's if you are calculating your grid from the beginning. Now if your grid is measured from center to center, in your plans the grids are measured from where to where? The distances in your plans are measured from where to where normally? Normally from center to center. So the column should be in the center or it should be at the edge? Should be at the center. Are we clear? But once again, it depends what you calculate exactly. Are you calculating the distances from the end to the end, or are you calculating center to center? So this is what I'm showing you. See here, if we keep another column here, now the software once again understand that this is the end border. So it will not keep anything outside. Are we clear? What about here? See, everything is kept inside. Here, it will keep it now at the center. Why? Because this is all inside. Are we clear? Okay. Here, you will see that once again it will keep always your column at the inside part of the building. Okay. Now, if you are measuring center to center, like most of the scenarios in your plans, what we need to do, I'm just going to delete the columns. Okay, I just deleted the columns. So what I'm going to do now, once again, I'll go for column 200 into 400. I'm going to remove automatic alignment. Okay, if you remove automatic alignment, it will understand that you want to put it at the center. So this is at the center. Are we clear? This is at the center. Got it? So it depends from where and how you are measuring. Okay, now if my column is not in this direction, I can go from here and keep the orientation to be 90 degrees, and then you can see that this is going to be the orientation of my column. Are we clear? It is one section, but you are playing with the orientation. Fine? Any questions till now? Okay. There is another method where you can do like this, and then you can go and draw as many columns as you want in each and every intersection. Are we clear? So hold in one point and then just pull from right to left. All the places will be drawn. If I want to change the column, I'll just choose the column. For example, this one, and then I will change it to 0, so it will turn. Are we clear? So you can draw at one time and then play with the orientation as you want. Fine? Okay. Sometimes your column is not coming at the center, exactly at the center. Now this is at the center. In my drawing, it is not exactly at the center of the grid. What you can do, you can play with the alignment here. So for example, I can push it 100. So you can see this has been pushed. If you don't want, you want to keep it at the center, then keep it as 0. Are we clear? By default, it will be as 0. Everything depends on your plan. Fine? Okay. Now let's say that I have drawn my columns. Okay, I have drawn my columns here, and then here, and then here I have drawn, and I want to draw a wall. Okay, I wanted to draw a wall. So what I go and do, I'll go for meshed wall. Now inside meshed wall, there are two types. Okay, there is mid here wall and there is mesh, which is normally a regular RCC, but it's not mainly taking lateral loading. This is taking both lateral loading normally and vertical loading. So we'll go for mesh. It will ask you what is the size. Okay. Yeah. Okay. So it will ask you what grade, what is the thickness. So for example, I want my thickness to be 300. Okay. And then it will ask you from where you want to draw. So I want to draw it from here to here, and then from here to here, and then from here to here. Got it? Okay. Now we have drawn this. If I go and see it in 3D, this is how it looks. Okay. This is how it looks. Now the correct thing to do for this particular thing. Now it shouldn't be one from the beginning till the end. It should be only to the floor level. So what you can do, see for any column, for example, I have one column which is not going to the top. It is only reaching to the first floor, for example, and I don't have something. So what I can do, I can choose a column. Now see this column. This is reaching where? This is reaching till the third floor. We have ground, foundation, ground, first floor, and second floor. Okay. So this is reaching to the second floor. I'll keep it as it is. This one, it says it's starting. Can you see here? It is starting from the base and it's finishing in the second floor. What I'm going to do, change it to first floor. So it came lesser. Change it to ground floor. So it came lesser. Are we clear? Depending on your size of, or depending from where to where your column will be active. Got it? Okay. Similarly for the wall, before you keep it as a core wall. Now it is single walls. Later you can keep them as a core wall. If you want to modify, and the correct thing to modify, you need to go from base to from base to ground. Are we clear? Okay. And then after we have finished from here, let us keep it now the same, and we will see later the effect. So we have drawn the columns, we have drawn the walls. Next step is to go for the beams. Okay. Now beams normally you will not draw in 3D, you will draw in 2D. Beams will not be in the in the foundation level, it will be in the ground. So I'm going to go for beams. Once again, it will ask you the same thing. Are you going to use normal weight concrete? Are you going to use grade of C40? What is the grade? What is the size? Normally, the recommended thing to do, go with the minimum section and then increase the section if it's failing. Okay. So I'll go for 200, 400. Normally, the lowest sizes used for columns and beams here in Oman, normally 200, 400 and 200, 400. Okay. So once again, you can go and highlight. I'm going to highlight, and then I'm going to highlight. Okay. Fine. Okay. Although the most appropriate thing to do is to have a continuity. For sometimes if you are modeling it in this way, you will still have an issue of what you call. You will still have an issue in terms of errors. And the most proper thing to do is to draw it from here to here. So it should be one continuous line from the beginning till the end. Okay. Now we have finished from this beam, and you can see in your 3D, the beams have been drawn where? Only in the ground. Okay. Now if you return back here in the construction level, you will see that unique. Unique means it is different from the other floors. Okay. If I click on ground, it will ask me, do you want it unique, or do you want it the same as 3 or the same as 2 or the same as the base? Now we have already finished from ground floor, and I want first floor to be exactly the same. So what I'm going to do, I'm going to keep 2 to be similar to what? Similar to 1, right? Because I have finished drawing in 1. Okay, and then I click on OK. Now you will see whatever you have drawn in the ground floor, it has been pushed to the first floor. Have you got it? Okay, it is like copy. Now after you finish from here, click on unique. So it will be different. Are we clear? Okay, uniqueness, it means that each and every floor is different from the other. I just copied it because what I know in terms of ground floor we don't have slab, but in terms of first floor we have a slab. Okay, so I just copied the beam and then I'll be drawing the slab. So I went to the first floor, ground floor there will not be a slab. We are going, unless you are talking about basement. If you have basement, ground is to be modeled. There is no basement, there will not be a ground floor slab in the design. Okay. Now we came to the first floor. We are going to go for slabs. Now it's asking you, are you talking about slab on beam or flat slab or precast or whatever type? Slab on beam. It will ask you what is the size. For example, 150. Normally we can start from 130 in terms of slabs. I'm going to highlight. So, okay, and the place of the left I'll keep it empty. Okay, for this for this example it's easy because all the slabs are coming to be uniform. I mean purely, let's say, rectangle. In certain scenarios you will have something which is not rectangle. If it's not rectangle, sometimes Tekla will not read it properly automatically. What you need to do, like for example, let's take this one. Let's assume that it's irregular in shape. Okay, if you take it to Tekla, you will see later, if you zoom in, you will see that there are some empty spaces. The proper thing to do, you will go for slab. Once again, choose choose your slab number 1. Okay, one thing to be taken into account, you need to go and remove select bay, and then you need to specify from here to here. You need to go to the edges of the slab. Okay. Okay, so I will not go for bay. I'm going to go for drawing it to the points. Are we clear? Okay, so once again, if it's simple in shape, use the automated system. If it's not, go and pick the point. Are we clear? Okay. This this is a left area, so I'm going to keep it. Let's say that I want to have a staircase somewhere. Let's say here, for example. I'll just delete it because there will be a staircase. Okay. Now you can see this is how it looks now. Okay, this is how it looks. And let's say, for example, this will be there because it is a stair. All the other columns, this one, this one, this one, this one, all the columns. Okay, I have chosen the columns, almost all of them. Okay, and I'll just keep them that they are going to go to only second floor. Okay, so I have only the lift, and I have only the room of the third. Are we clear? Now you can draw your beams here. So this is going to be my beam. Now of course here a wall, so you don't need to draw a beam over the wall. This one and this one. Okay, so we have drawn here. You can go for slab in the third. You can see only there are two areas. Are you clear? No columns in the other areas, right? Can you see all the columns are only to the second floor? Only these two areas. So when you go to the third, only you will see these two areas. Okay, so we'll go for slab on B. This one. Yes. You can keep it and you can remove it. I'll tell you later. Okay. You can keep it and you can remove it. It's okay. Okay. Now, can you tell me why it was not working when I was trying to model it previously? See here. Now, if I pick slab on B, and I try to go and model, I kept it, for example, as 170 or whatever is the value, you will see that this will come. This will not come. Why? Because this is purely on walls, not on beams. Are we clear? If it's on walls, it's not a solid slab. It is should be flat slab. Are we clear? Okay. So choose your size and then keep it wherever you go. Are we clear? Shear wall, and if you have a slab which is connected by columns, for example, if you don't have beams in general, which one? Beams, beams, and beams, majorly by beams. Are we clear? Okay. Now we have modeled everything. Only remaining thing is the foundation. Okay, we'll go for the foundation and then we'll go for loading, and we will see the output. Okay, we will go for the base. Now you can see that you have these are the supports. You need to go for foundation. Different types of foundations are there. So you have, for example, bad base. Okay, you can click and you can choose whether you want it to be square or you want it to be rectangle. Okay, if it's rectangle, you want it to be depending on the moment, or you want it to bending or fix in one direction and the other one is changing. Once again, if you are keeping it to be isolated foundation, it can be square or it can go with the moments of the column, which is more accurate. Okay, so we'll keep it rectangle going to the proportion of moment, and then for example I'll draw here. Now it's showing for you square because still you didn't, what you call, you didn't analyze. Whenever you analyze, it will be changed. Okay, let's say for this as well, I want to keep, this one I want to keep, and this is not your design. Even if it's overlapping here, because you still didn't do the loading, you still didn't do the analyzing, so it does not mean there is an overlap. Are we clear? It's only for drawing now. For example, here I have a large area where columns are very close to each other. So what we can do, we can go for area or rectangle, and this is going to be my, I have chosen, and then you need to pick one of the columns. It says for you pick a column. So this is going to be one foundation for a couple of columns. What is this foundation? Raft. Okay. So same. This is going to be for isolated. This is for raft or mat. Are we clear? Okay. Here for the state, for the what you call, for the lift, you can go for strip or you can go for raft. Depends. Mainly, a lot of people will use only raft. Okay. If you want a strip, then you can go strip wood. Choose from here strip. This is the first one, second one, and then this is the third. Are we clear? If you want a raft, then once again go to rectangle, choose, and then this is your raft. Are we clear? It's very simple. Okay. And once again, this is only drawing. The software didn't start design. Okay. I'm going to input the other areas as isolated. I just wanted to show you how to choose between raft and the other things. Okay. Now, one thing to be taken into account, we will come to it later. One thing to be taken into account, make sure that you are choosing correctly uh, the allowable bearing capacity. The bearing capacity depends on your soil, what you call soil condition. So if you are designing in a place which is, let's say, rocky, you can go for 150. If it's a place near to the sea or let's say sandy soil, then you can go for 100 or lesser. Okay. Any question till now? Okay. Now after we have finished from here, after we have finished from model, we have edited whatever we want to edit. We want to go for loading, but before loading I want to do something which is your which is going to be your staircase. Okay, which is going to be your staircase. Just concentrate with me here because it is not, it's not hard, but you need to concentrate. Okay, there are two methods of making the staircase. One of them is by going to model, going for level, and then choosing, here we have ground and we have first floor. Now the stair is going from one floor to another floor, or it's going to half and then landing and then half. Do you have one stair going from one floor to another floor, or normally it's going from floor to half, which is having landing, and then from landing to the other half? It goes half, right? Okay, now remember that you are having floor to floor only. There is nothing half. So what you can do, you can choose from here and then click insert above. The software will understand that you want to have a half level. Okay, now what is the height here? 3.6, right? If I go for insert above, the software will cut it into 1.8 and 1.8. Got it? So it will draw for me another level, and then I need to draw in that level. Or if you want, there is a better way to do it, especially if you don't have a lot of staircases. I'll go and take this beam, I'll go to edit, I'll copy, okay, and let's say for example I'll take it from this position to half of the column. Are we clear? Because the column from the bottom till the top, it's a one full floor. Are we clear? If I keep it till half, then it is half of the floor, and you can see it's 1.8. So I clicked here. Are we clear? So this is like a reference for me. After I have drawn from here, do you have any difficulty in drawing this half beam? Okay. Now I need to draw landing. What is the width of the landing? Width of the landing. Length depends on your length array. Width of the landing will be 1 meter. Okay, will be 1 meter. So it means that there will be a slab of 1 meter with it. How to draw? I'm going to go to model. What I'm going to do? I'm going to draw from this point straight to this point. A straight line beam. Okay? I'm going to take this beam. I don't want it for the full length. I want it only for the reference of 1 meter. There are how many points in this beam? Can you see? There is 1 point here, blue line. Can you see? There is a second one here, and there is a third one. Can you see? If you click on any one and you try to pull it, it will reduce in length. So I'm just pulling it until I reach to a position of till I reach. Can you see the numbers at the top? It is 0.988, and I'll go till I reach to a position of 1 meter. Are we clear? So now what has happened? This went from the full length to 1 meter. How to convert? We can convert from here. It is 1 meter width. Are we clear? Okay, so we have drawn this. What I'm going to do, I'll go for edit, copy it from this position till this position till half. Where is this center? The center here. It's not complete. What was the center? It's 3.5, 3.5, so it should be here. Okay, now there are other methods for you to clearly see, and I'll show you later how you will see easier than this way, whatever I'm doing. Okay, now what? Can you tell me why I have drawn these beams? So it will be easier for me to draw the slab later for the what you call landing. So I'm going to go to model, slab on beam. This is the first point. This is going to be the second point. This is the third point, and this should be the end point. Can you see? Now the beams have helped me in drawing. Okay, I'm going to delete them later, only for the reference of drawing. Have you seen what I have done? I have done the landing, right? Now this is a function of having this beam and this beam. Why do I have this beam? For drawing the slab, I use this beam and this beam, right? For this beam to draw the stair, because it should go to half, right? So what I'm going to go, I'm going to go to slab. Now, in which view we have drawn the slabs previously? The regular slabs in which view? It was in plan, right? We went to the plan and we have drawn. If you are drawing staircase, it cannot be drawn in plan. Why? What's the meaning of plan? You are seeing it from the top, right? Okay. In plan, do you see different levels or only one level? Stair is having one level or two levels? Two levels. So you cannot draw in a plan. Are we clear? Can I draw in 3D? 3D, you can see more than one view, one floor. Okay. So if you are drawing a stair, it should be only drawn in 3D. Okay. Now how to draw a stair? First point, second point, third point, and then you are going here and checking where. Make sure that you keep rotating, so you will make sure that you have picked the correct point. Okay, and this is your first part of the stair. Are we clear? Depending on your width of the stair, your stair can be big in width, can be smaller in width. The steps are the same. Are we clear? First, what you need to do, you need to draw a beam in the middle. After that, draw three small beams or one long beam, cut it to 1 meter, put it in three position, beginning, start, and end, so you can draw your stair. Are we clear? Okay, now what I want to draw the other side, right? To draw the other side, what I need to do? Same, slab. It should be starting from where? From this point. to this point, to where it should go here, right? Somewhere here, and then till here. Yes, it does not go correct. This point. Okay, so you can draw beams in order to help you in whatever direction you want. Okay, it will make your work easier. Okay, so I kept drawing, and you can see that this is your stair. Are we clear? Okay. Do you require landing here? At the top, do you require landing? Because it's directly the floor, right? We don't require landing. Do we require here? It's here? No, because actually there is a ground floor. Are we clear? Okay. Now let's say I want to copy. I don't want to do it once again. What you can do? This is the first flight, second flight. This is my landing. This is my beam that I need to copy. Are we clear? What I'm going to do, I'm going to edit. I copy it from this reference, from the ground floor to the first floor, and this has been drawn as a second floor. Are we clear? That's only if you have a second floor, but take into account we don't, because of the floor. Okay, if I have only another floor, got it? Any question regarding modeling of staircase? Yes. Yes. I'm going to review. Any doubts regarding these? Okay. So all the beams which are in the intermediate should draw. I mean, should erase them. Yes, if you are having the same dimension and the same things. If it's not the same thing, you cannot copy it. Okay. Are we clear? Any questions? Now, after we finalize, we need to go to load. In terms of loading, first we need to go and identify the load cases. Load cases. How many load cases are here? Self weight excluding slab, self weight slab weight, dead, services, imposed. You can change whatever you want. So, for example, you can have wall here. You can add another one which is water tank. You can add another one which is, for example, AC. You can add another one, for example, which is wind. Are we clear? And you can add as well seismic if you want. Got it? Okay. Whatever you don't want, delete. Remaining you need to keep. Okay. And I click add or okay. Now you will see that these are coming for you. Whatever you have pre-identified, you will see them here. I will not go for all of them because they will take time. So for example, dead, if I want to put dead, I have chosen here it's dead. Okay, I will go for load. Do you want it to be level or slab or area? Okay, now if you are having level, it means for all that level. Okay, the same for a slab. If you only want your load to be available only in a certain slab, then it's going to be area. Okay, like for example level, I want my loading to be here. Okay, it will ask you how much is the load. So for example 1.5. Okay, and it will ask me where. I'll tell that keep it here. You will see that all the floor is having all the floors and that level is having the load of 1.5. Are we clear? Okay, now if we change for example to water tank, I want water tank for example to be here. I don't want to be level. I will go to area. For example, let's keep it as 9. I'll keep it only in this area. Have you known the difference between them? Area for a particular slab, level is for a full one. Okay. You have as well wall. So we'll go for wall. Now if you are going for wall, is it a panel load or is it a member load? It is not a panel load because this is an area load. This is a line load. Are we clear? This will be happening in slabs. This will be happening in beams. Are we clear? So full UDL. Let's say for example, normally the height of for 1 meter wall is 3.2 or 3.15. So let's say for example 9 once again. Now it will ask you where you want to keep it. Can you see wherever you want to go? Can you see here? So I want it here. I want it here. I want it here. Wherever you want. Are we clear? The decree. Do you remember the issue for the column? The load coming on the column. Here it will not come if you are modeling it in this way. Okay. Fine. Depending on where your wall is. So if you have a slab which does not have a wall, you don't need to do. It depends on you. Got it? Any question regarding this? No. Okay. Similarly for water tank, for AC, for life load, dead load, they are the same concept. Okay, dead, life, water tank, AC, all of them are area load, except for wall. Okay, and then we have wind load and we have seismic. Okay, I'm going to explain them not into details because not all of you are having seismic and wind, but anyhow, for your information. Now, can you see that when you click on wind load here, can you see it is inactive? Can you see it's inactive? You cannot click anything. Okay. Now to make it active and let the software calculate it for you, what you need to do, you need to go to model. There is something called roof panel and there is wall panel. Are we clear? Now if you are seeing this, what the software will understand? Will the software understand that there are walls between the columns and beams? According to whatever you have drawn, do you have any barrier covering the frame? No. Okay, in reality there will be, right? Okay, so now what you need to do, I need to tell the software that there is a wall panel from here to here. Are we clear? If this is the wall, then it will be like this. So the software will understand that this is covered, that's not open. Are we clear? Now can we click on load, check whether it's active or not? Is it active? Okay, why? Because you have done the panel. Are we clear? Okay. Now, if you have an area which is not covered, fully open, will there be a large effect of wind? Are we clear? Okay. Now, when you go to wind wizard, it will ask you, are you going to use BS standard? Yes. Are you in UK or Ireland? No. So we'll click on other. Next, altitude. What is your height compared to the sea level? So for example, 1.5 above the sea level. Density of concrete is the same. Ground level, starting from which height here for you? It was at 0. Speed. What is the wind speed? Depends on your site. So let's say in Oman normally around 30 or Muscat. Your location, is it in town or country or sea? What is the difference between this? Sea means near to the sea. Country, أماكن ريفية, villages normally. Town, city areas. What is the difference? ليش البرنامج مقسم هنا town, country, sea? Wind will be more near to the sea or less? More. It is compared to the other areas, it's more. So you need to classify it separately. Town and country, why it's different? Where do you have normally high buildings and covered areas and everything? Town. So in town, the airflow will be lesser than the villages. Are we clear? So it depends on your project. If you are having near to the sea, then it's sea. If it's a village area, not covered a lot, then country. If it's a city, then it's going to be a town. Got it? Let's say it's a town. Here you are not going to have any changes. It says for you what is the distance from sea to site. So let's say 5 kilometers for example. What is the distance from the edge of the town to yours? Once again, remember you have sea and you have your town. From your place to the end of the town, how much is it? Approximately. So let's say 3 kilometers. The software will calculate automatically the factors. It will calculate for you the pressure. Doing this, you have done the wind analysis. You have finished wind analysis. Okay. You have finished the wind loading. Software will run the analysis later. Earthquake, if you want the earthquake, you will go to seismic wizard. Okay, you will go for code spectra. It will ask you what is the height of the building. It is automated. You need to ignore which floors. Which floors will be affected by earthquake normally? Above the ground or below the ground? Normally above the ground, right? So you need to ignore anything below the ground level. Are we clear? How many stories? Two. Automatically the software is calculating. We are having first and second one. Okay. What is the soil profile? Is it hard rock, very dense, stiff soil, soft soil, depending on your site condition? Okay, normally in Oman either rock or very dense soil. Occupancy, it depends on your it depends on how many people. If you go to this code, which is UBC, it will tell you on how many people are using the building. If you have a building which is having a lot of users, then it will have more occupancy. Are we clear? Similarly for importance. Muscat is in which zone for seismic? Oman is having two zones for seismic. Muscat is in 2A. Okay, Muscat, Musandam are in 2A. Next, we have irregularity, no? Which structure type? Are you having steel, moment frame, concrete? Concrete. The other direction, first direction, second direction, concrete. System. Are you going to use bearing wall or building frame, moment resisting frame, dual system? Which system you are using? Dual system. Dual system. What do you have? Here, what do you have? Do you have only frame, concrete beam and column? Or do you have shear wall as well? Shear wall. So you have two systems, shear wall and frame. Are we clear? That's why we say dual system. Got it? Okay. So concrete shear wall with concrete with SMFRF, that's semi moment resistance frame. Okay, so concrete shear wall with frames. Everything will be calculated by the software. Now you need to take the loading here. Okay. So we have taken the loading, shift it over there because all of them they will contribute in seismic. Next, and then finish. So you have included the earthquake parameter. Are we clear? The only thing that you should know your site, what is the parameters of your site, characteristics, and then you can input. Otherwise, you cannot. Are we clear? Okay. After you finish all of this, you can go as well and do validate to check whether your drawing is right or wrong. So you can see that you have support exists within mat. Normally, if you are having a rough foundation, you don't require to have what you call support. Are you clear? Most of the software they will do it in this way. So you can go and delete the software, the what you call the support. I'll show you how. The major problem that we are having is this one. It says for you, if you read it, it's very clear. It says for your rigid diaphragms on sloped slabs cannot be defined. Okay, now where is your sloped slabs here? Stair. Okay, what is the meaning of diaphragm? This is too advanced, but diaphragm is the action of the transfer of loading horizontally from one element to another element for earthquake. Okay, so the horizontal will push the other horizontal element, so it will contribute in resistance for earthquake. For the incline, it will not happen. Are we clear? So we need to remove the diaphragm. So I click on these two sloped items. There is here, it says for you include in diaphragm. Include in diaphragm. So I'm going to remove the tick, and then we are going to revalidate. That has been going. Okay. Now here you can go to the foundation. Where is the mat? You have mat foundation here, right? So I'm going to choose these. Click delete in the keyboard. Okay. Okay. Or you can click using the mouse. Choose the first support, delete it. Second one, delete it. Can you see now columns are acting alone? Have you seen? No. Although it will not affect here, but most of the software when it comes to math, you don't require to keep a support. Can you see that has gone? Okay, so now we learn problems and how to solve the problem. Now only problem that you are having is with this one, which is the wind. Why it's happening? Why it's happening? Because we have drawn only in one direction, and we assume the wind is coming from all directions. So you need to continue drawing the whole panel for all the directions. Are we clear? For the meantime, because most of you are not having wind and earthquake, I assume, if you are having them, just draw in all the direction, and then it will be okay. If you are not having, delete it. I just showed you in such a way so that you will know. Okay. Now validate. Can you see everything is okay now? Got it? So before you go to the design, make sure that everything is correct. Okay. Now we will go for, you don't need to go to analysis. Directly go to design. Design concrete static. Before that, we forgot the combination. What is the meaning of combination? Factor of safety is right. So you can see load cases, combination, generate, next. So you can see now how many the software has defined for you. How many combinations? Three. You can see first combination is taking dead and life. 1.4, 1.6. Second, 1.2, 1.2, and 1.2, taking into account wind. Third one is D plus 1.4 of wind. Are we clear? Okay. Now, if you are not defining, if you have not defined wind as a load, it will not come here. It will only show you dead and live load. Are we clear? And this is a mistake of most here. So next, finish. Okay. Now let us go and design. Okay. Now can you see how many failures are there? How many warning? How many pass? How many failure? All of them are pass, except one. Remaining are fail. Warning. Where the warning are? Mainly the warning in the blend beam area. Are we clear? Why? Okay, because here you are not modeling the slab, so the software will not understand that anything is taking it. Okay, so it will have some tension. You can ignore this one because in reality you are doing a slab. Are we clear? As long as it's not failing. So for blend beam you can ignore, but the other areas you can modify. Okay. Now let us go to the area where failures and how to modify it. So click here. Now if you are putting auto design, even if you do your changes, it will return back to the same. Are we clear? Okay. Now there are two ways of solving it. Either by increasing the cross section or by adding reinforcement. If I remove auto design, I will go to this beam where it has failure. Right click on it, and then I'm going to go for interactive design and then static. Okay. You will see that this was okay. Which part was failing? Can you see here? It says you have a problem in longitudinal bar, and the issue which is happening with you is in terms of deflection. How to solve the deflection? Increase the depth. Increase the depth. Okay, increase the depth or increase the size. Okay, so we'll go. What is the beam here? 200 into 400, right? Just change it to, for example, 200 into 500. So keep all the beams and columns 200, 400. Whatever is pass. Whatever is failing, only change it. Okay, so 200, 500. If it's still failing, increase. Only increase those who are failing. Okay, failing. Yeah, you can increase the depth, or if you want, you can increase the reinforcement as well. Now we are redesigning. Actually, okay, still it's failing. Okay, because the span is huge here. Okay, now it's 200 into 700, but it's still showing showing a failure, and you can see here. Okay, now where is the failure? The failure here. Can you see this X? Okay, it says for you warning or failure, and we want to solve it. It says the ratio is 1.65. It means that the required is more than the provided. Okay, the required is more than the provided. In which region? Top or bottom? The failure is in top. So I'm going to play with the top. How many bars are here? How many bars? Two. What you can do, you can go for example for four. Anything has changed? Why it's not changing? Oh, this is okay. Now, see it was 12, right? And it was failing. Can you see what I have done? I went and increased the diameter. How would you solve it? Either by increasing the reinforcement or increasing the deflection, the depth. So now if you change it to 16, you will see it's coming to be passing. Are we clear? Click on OK. Now how many failure are there? Got it? Fine. Let us go to the foundation. We will ask design from here. We will go and design. We will ask it to design first the design bad bases. Have you seen now they have been shifted to a what you call rectangle? Previously they were square, right? So now according to their load, they have changed. Got it? Okay, so they are safe. Why they are not active here? Now of course in your design they will be bigger because your load is bigger. I have put only two loads here. Okay, what about these? Because once again, if you go to the foundation, they are designing bad base separately. They are designing their mat separately. Are we clear? So now what we have designed, the isolated, right? If I go design mat, now they are okay. Got it? Fine. Okay. Now going for the structure 3D, everything has been done. Everything has been designed. Okay. Through that we have done few loading. I have explained the idea of putting different layers. Okay. Now the next step is going to get the reports. Okay. Getting the report and getting the drawing. If I go to the report from here, go to, you can go for material listing, show report. It will show you exactly how much. Let us take it to, for example, here. This is what I was saying for you. These will not be available if you are using the education. You cannot transfer. Okay. So this is how the software has shown you. It says for you, you have used 200 into 400 for 88 beams or spans. Total length is 391. 200 into 700 this much. This is the total reinforcement used. This is the total volume of concrete. This is the embedded carbon. Are we clear? This is for the beams, this is for the columns, this is for walls. Going for Tekla once again. If you want the full design, then you can go from here for building design. Building design and show report. Now, everything that you have done from the beginning till the end, everything that you have seen, it will be given in a PDF. It will take some time because building design normally is having a lot of pages. So this is your building design, and you can see the this is the cross section. This is like Excel. It shows you how much is your moment, d dash k over k dash, everything that you have studied. It is shown here for all beams, columns, and it goes on. So it's around 66 pages for whatever we have done. Shear capacity for foundation, different things will be available. Okay. This one sizes. Now of course there will be a lot of other details There will be a lot of other details, but I think these things are more or less will give you 60-50% of the whole software. Okay, now for drawing, anything for report you will get it from report. Anything for drawing you will get it from here. So going for drawing, let me close this one. I'll go for uh, 2D and I'll go for drawing. Now it will ask me what type of drawing you want. So for example, I want a foundation layout. I'll click on foundation layout and then click on OK. The software will directly open for you the AutoCAD and it will show you the sections generated without you drawing them. So all of the sections, okay, all the sections are there with whatever you have drawn, with the sizes, with the orientation, and this is with the reinforcement, and this is with the schedule. What is your LX, LY depth, and this that. Okay, and then with the material listing. Okay, if I want, for example, I want to go for ground floor, I want to show beam schedule. So I'll go for beam schedule, click on OK. So you need to go for the view and choose whatever is relevant. Right. Still it didn't finish it. Still loading. And this is your beam schedule. Okay, this is your beam schedule, which is showing for you the entire reinforcement for each and every beam. Okay, what else you can see? The arrangement, if you want general arrangement, you can go here. This is the general arrangement, showing you each and every plan is having what exactly. So you can see this is your ground, showing you only beams and columns in the wall. First floor, for example, beam schedule. We will see column schedule after a few seconds. Although it's weird, it should show you the cross section as well. Yeah, you can get as well the column schedule. You can choose whatever frame you want. And this is how the cross section is shown for you from the beginning till the end, with each and every floor, with the depth and all the details. And you can see here it's blocked because it's not going to the last floor. Some columns were going only to the first floor, right? Some columns are going to the second floor. That will show you. Complicated question. You should use your logic to judge. If the values are reasonable, okay. The values you can see that they are irrelative. You need to question. That's why they are asking you for one manual. One last thing. Let's say that I have done this one. I want to convert this one, take it from here to Revit. Okay. Or I have a building in Revit and I want to change it here. So we'll go to BIM integration. In BIM integration, you can see that there are different things. You can send it to STAD, you can send it to Robot, you can send it to Adapt, you can send it to Cellbeam, Revit, different things. For example, we are sending it to Revit now. I'm going to send everything. Yes. Huh? Different type of analysis. Are you learn? This is too advanced. Are you doing dynamic or static loading? Static. Then first order. If you are going second order, dynamic. اللي عندك window غيره. برنامج فيه different types of analysis even for static and dynamic. Okay. You have, for example, push over. You have spectrum. So it depends انت على أي level of detail you. Automatically he will understand. If you are not doing wind and earthquake, you will not go for second order and complicated analysis. Okay, so we have now taken the file. I'm going to open Revit now. Just concentrate here with me. Can you open Revit? Here? Can you see Revit? If you didn't open, leave it. If you didn't open, leave it. Okay. I'll tell you what I wanted you to see. In regular Revit, you will not see Tekla integration here. Okay? In regular Revit, you will not see Tekla integration. You need to have it as an add-on so it will appear. Okay, so I'm going now to Tekla integration, integrator. Okay. Next. Are you going to export or import now? Import, because we are bringing it from Tekla to Revit. Are you sending from Revit to Tekla or Tekla to Revit? Tekla to Revit. So import. Which file? The file that I have kept now. And this is the element that I have. Okay. If I want, I'll send it to a robot. And this is the modeling robot. So within 1 hour, if you are so good, you can not do only your structure in one model, in one software, you can do in 10. Right? Now let us say the opposite. Let us assume that we don't have Tekla and we have our, okay. Let us say that we are having our Revit only. And I want to transfer from Revit to Tekla. Okay. Now you need to understand two things because a lot of students are having a lot of confusion here. When it comes to Revit, there are different elements. You have architectural elements. You can see architectural column and you can see as well structural column. Are you clear? If you are drawing with architectural column, no structural software will read your model. Okay. If you are drawing with the architectural element. If you are doing drawing in Revit with structural elements, all the software will read it. Are we clear? Now this has been transferred, so it's a structural one. What I'm going to do, I'm going to go and take it to Tekla now. So I'm going to go to Tekla integration, integrator. Next. Now we are sending from Revit to Tekla. So first time export. Next. Save the file. Revit to Tekla. Okay. Now what I'm going to do, I'm going to open my Tekla. I'm opening my Tekla. We will go for new. From where we said we are going to bring the model, BIM integration. Which one? Okay, import. All of these are export. This is import. So import RT. Next. Which unit? Which code you want? And this is your model from Revit to Tekla. Got it? So we have done modeling, design, analysis, wind, earthquake in, let's say, 1.5 hours. The same you can do for your project. It's not complicated. Okay. I'll show you. Okay, for design of slab, let me open the previous file. عندك اجتماع ساعة 2. Okay. For slab, design, design slab. Okay. Two methods are there. Okay. Either you will increase the depth 150, for example, to 180, and design slab. This is my slab. Huh? Still. Okay. Keep 220 or 230 to be your maximum. The other way, click on the slab and then you go to review and then go for slab reinforcement and change the reinforcement of the slab. So from here, go to user bars, choose what reinforcement you want and what size you want, but remove auto design. Okay. Now you can see here what is the diameter used here for this 10 at 150. 10 is very small. If you go for 14, 15, or 14, 16, it might be same. Got it? So it's from here, for example, 16. We'll keep it at 200. This is for bottom X. Same thing, you need to go for top X, top Y, bottom Y, and you keep changing. Are we clear? Oh, top Y. Same. I'm going to go for user bar 16 at 200, for example, and then we'll go for Y. You check how much and keep playing. Okay. Here. And then we have top X, I believe. That is already okay. Then bottom X. Okay, and then after that you need to redesign. Once again, make sure that you have removed auto design. Okay. make sure auto design will not be there. Keep playing and then it will be set. Right? أقصى 70 لحظة. أول شيء have you changed the material وكل شيء loading commands كل شيء سويتي؟